You ever really think about the difference between a photograph and a movie? A photo, well, that's just a single frozen moment, right? A car in the middle of a turn, a player caught midair. But a movie? A movie tells a story. It connects all those moments. So the big question is, how do we get a computer to see the whole story and not just one single picture? Let's dive in.
See, it all comes down to two really different concepts: object detection versus object tracking. Detection, that's the snapshot. A computer looks at a single frame of video and goes, okay, that's a car, that's a person, there's a ball. But tracking is where the story happens. It's the ability to follow that exact car as it moves down the block, or that specific player as they sprint across the field. It's all about understanding what happens over time.
And that's the core of the challenge we're talking about today. How do you get a machine to go from seeing a simple snapshot to understanding the full dynamic story? We've got to teach it to see the world not as a bunch of disconnected images, but as a continuous flow of events, just like we do.
All right, so to understand the story, you first need to see the characters, right? Well, in the world of computer vision, one of the best tools for seeing has a pretty catchy name. This is what gives our system its powerful set of eyes.
It's called YOLO, and yep, it stands for You Only Look Once. The name actually describes its superpower perfectly. See, older methods had to scan an image over and over again to find things. But YOLO? It looks at the whole picture just one time to find everything in it. That makes it incredibly fast and super efficient.
And just how fast are we talking? Get this. YOLO can process more than 45 frames every single second. Now, to put that into perspective, most video you watch is only 24 or 30 frames per second, so YOLO can analyze video faster than we can even see it. That is an absolute game changer for anything happening in real time.
Okay, so our system has these super fast eyes. It can spot every single person, every car, every object in every frame. But that brings us to the next problem, doesn't it? How does it know that the car in frame 1 is the exact same car in frame 2 and frame 3 and all the way down the line? How does it connect the dots?
And this is where the second piece of our puzzle comes in. We need to give the system a kind of memory, a brain, really. Something that takes what the YOLO eyes are seeing and links it all together. This is how we make the leap from just seeing stuff to intelligently tracking it. The whole idea is what's called persistent identity. Think of it like this. The tracker's job is to give every single object it spots a unique name tag, like a jersey number in sports. That car becomes car 12. That person becomes person 4. And no matter where they go, even if they disappear behind a tree for a second, the system's whole goal is to keep that same ID stuck to them. And it does all this with a really simple but totally brilliant 4-step loop. First, it spots all the objects in a frame with YOLO. Second, if there's anything new, it gets its own unique ID. Third, and this is the clever part, it predicts where each of those objects is probably going to be in the very next frame based on how fast it's moving. And finally, it matches the real objects it sees in that next frame to its predictions, confirms their IDs, and keeps the story going. Spot, ID, predict, match, over and over and over, dozens of times a second.
Now, this isn't just some cool tech you see in a lab. It is a genuine superpower, and it's being used out in the real world right now. So let's take a look at where this kind of tech is already changing pretty much everything.
Take retail, for example. Stores are using this to understand how we actually shop. By anonymously tracking how customers move, they can see which aisles are crowded, where people are stopping, and even predict when to open up a new checkout line to cut down on your wait time. In sports, oh, it's a complete revolution. Imagine tracking every single player on a soccer field or basketball court for an entire game. Analysts can now measure players' top speed, how far they ran, look at complex team formations. They're getting stats that were just impossible a few years ago. Its role in transportation is just as huge. Smart cities use this to watch traffic flow, which lets them optimize stoplight timing to cut down on congestion. And for self-driving cars, this is absolutely non-negotiable. They have to track every other car, every cyclist, and every pedestrian to have any hope of navigating our streets safely.
And finally, think about security and public safety. This tech can monitor secure areas, track vehicles that aren't supposed to be there, or analyze how crowds are moving in busy places to help keep everyone safe during a big concert or event. So from telling a simple story in a short video to completely reshaping our cities and industries, multi-object tracking is an incredibly powerful tool. It gives us this brand new way of understanding the complicated, moving world all around us. And that leaves us with one final thought to chew on. As this technology gets better and more common, what do you think we all stand to gain from a world that can be observed this closely? And what new questions might we have to answer?